Welcome, Professor Pragyan Chakrabarti. Today at the Zena platform, we have someone very special, that is Professor Pragyan Chakrabarti. And as I can see from your CV, you have a very impressive career. Graduated in electronics engineering from Nagpur University, completed your MTech from the prestigious IIT Kharagpur, and went on to receive the PhD in engineering from NIT. And then you researched at a CNRS institution in France. And there also you did some very, very pioneering work. And then starting 2001, you began teaching. And after that, you have taught at many institutions as a professor and in different capacities. So we have here with us Professor Pragyan Chakrabarti, Principal Director of Click, a company dealing in finding solutions to problems in the field of electronic communication. I see that even Professor Randy Hopt once noticed your ability to find clever and practical solutions to the antenna array problems. Mr. Chakrabarti, you have distinguished yourself in the field. This doesn't come overnight. It has a long and sustained chain of efforts. In course, I shall, of course, ask you about your main achievements, like redefining signal and taking on William Shockley and so on, who was a Nobel laureate. So we'll start with the beginning. We'll begin with the beginning. For the benefits of our viewers, please tell us what is a signal and what is communication, and what inspired you to pursue a career in research and teaching in this field.
Okay, thank you so much, sir, for having me here in a discussion. Uh, well, I'll talk about what inspired me to join the electronics field, the electromagnetics research field first, and then talk about signal. Now, electromagnetics engineering as such, uh, it stems from the phenomena uh, at the very basic level, say an atom. So it is well known that in an atom, electrons are bound to the nucleus due to an electromagnetic force. So that means if electromagnetics, the power of electromagnetics doesn't exist, even an atom would not exist. And that means the entire universe will fall apart into a kind of formlessness without the power of electromagnetics. So this inspired me to take up a career in electromagnetics engineering or science, so to say. Uh, and regarding signals in communication, well, uh, I actually found the existing definition of signals uh, quite inadequate to uh, the current use of signals as such. For example, in electronics, we talk about sinusoidal signals, signals which are determinant signals and indeterminate signals. I mean,
Yeah.
so the thing is that I corrected the concept because every signal, the signal definition itself had the term information. So it was there as if every signal should have an information. Whereas signals like sinusoidal signals, sine wave, cos wave, and all those things doesn't require, they are not, they do not contain information, because as per Shannon's theory, anything which does not have a predictability uh, contain information. A completely predictable, a completely determinant signal doesn't contain information. So
Yeah.
I
Yeah.
specifically said that this we can avoid information, the part of information in it, because a signal may or may not contain an information. So it was very basic and it was widely accepted. I think this particular work made quite a good impact, though in a small way, but it good impact as per my work is concerned. It got widely cited in various journals and magazines and across various disciplines, research articles in medical
Yeah.
science and arts that quoted my
How did you
definitions.
get, yeah, but how did you get interested in this field? Any special incident or event or your teacher who influenced you or?
Uh, Unfortunately, that is, in fact, not the case. I mean, I just get inspired by uh, the the very fact that I'm able to ask questions to myself and see and try to check the correctness of everything before. I do not take things just like, cram it up. Okay, if you cannot understand, cram it up. So anything I do not understand, I just leave it uh, and analyze it, and then give my own version of the answer, which quells my questions, which answers my set of questions. Okay, so that's the way I go about it. I mean, uh, I cannot relate it to any particular person as
Any
such who has
specific
been.
incident. Yeah,
Yeah.
but you have contributed to several things. Now, which, in your opinion, was the proudest moment when you felt that, okay, this is it?
Well, so far, uh, my work on disproving the general diode equation, which fetched a Nobel Prize for William Shockley in 1956, uh, was the proudest moment, because I could do something very fundamental. And I was also nominated for the prestigious Shanti Swarup Bhatnagar Award in 2022. I did this work in 2021. It got published in IEEE Transactions for CAD, for integrated circuits and systems.
Yeah,
It is the
yeah.
topmost journal in its area in integrated circuits. And then subsequently I was nominated for this award. And by the way, it was the most prestigious scientific award during those days in the year 2022. It's only after
Yeah, yeah.
24 this has changed actually.
But another thing I wanted to ask you, when you sort of disagreed with Shockley, or you proposed a theory which disagreed with his theory, did you feel jittery or were you afraid that people might attack you for, attacking somebody's idea? Someone, his Shockley and Bardeen are two of the biggest names in the world of semiconductors and transistors. So you
Right,
disagreed
right.
with Shockley. So how did you feel at that point?
I am actually, due to my fundamental understanding, I am immensely confident about what I do. That that doesn't deter me from, that the fact does not let me deter from my objectives. So that is one thing. And second, yes, of course, this is the fundamental equation for all electronics that we see around, the Shockley equation, and it's still there. It's still there for the last 75 years. It's still there.
Yeah,
So
yeah.
and the thing is that, uh, you know uh, I looked at very particularly, if you would like to know, I mean, whether it would be appropriate or not, to discuss a little more about the work which I did. Shall I do that?
Yeah, yeah, please. That's what I wanted.
Okay.
For
Okay.
the layman who doesn't understand what a
Okay.
semiconductor device is. Yeah,
Okay. Okay. So let me tell you that the general diode equation is not a device equation. It is rather a circuit equation. Circuit equation formed by two devices. One is the PN junction, another is the series bulk resistance. So here comes the difference actually. So when you have a circuit equation, that equation should comply with the extant circuit laws, right? So I proved that Shockley's general diode equation does not satisfy circuit laws, does not comply with circuit laws,
okay.
and which it should comply with, like the energy balance, say the Kirchhoff's voltage law. It's all about energy balance. Voltages are potential energy per unit charge. So it's about energy balance. It's universal. So this versatility exists with anything, whether things are linear or non-linear. One should comply with this energy balance, right? I prove
So
that. Uh,
what you are suggesting is that in his equation, Shockley did not account for the losses, or what was some difference in energy you were finding?
no, it was not about losses. It was about the balancing of energy between, say, the supply voltage and distributing it among, say, these devices, say, the junction as well as the bulk resistance. It is just about that. So he did not comply with it. His equation was say 70% uh, accurate, because it must say only 70% to the measured results, and the modified equation which I suggested, okay, which complies with all circuit laws and everything established thing, that matches almost 100% with the measured results.
So how did the people in other countries take to it? When you disprove or find flaw or some shortcoming in the theory of somebody who is as big as Shockley, then his colleagues or students or that group is not very likely to take very kindly to it. So did they react in a scientific way that is agreeing with you, or was there some discontentment?
Unfortunately, there was no reaction. If there had been a discontentment, I would have been happy to answer, So, but neither acceptance nor discontentment. Okay,
Okay,
so
okay.
it is still kept in abeyance. You'll see that only 3 or 4 citations have been made, and that's also very remotely connected. Just a general citation that such and such work has been done. It doesn't talk about that. It fundamentally negates the Shockley's equation. It doesn't talk about that.
But
And
Professor Pragyan,
yes,
as you said that this requires gut,
yeah,
and you were not afraid, you made your point very clearly, and probably because it was right, no one, they could not ignore it, but at the same time, they could not criticize it either. But in science or engineering or in any field of research, to have the guts to be able to do something which may not be completely acceptable to others requires a lot of uh, guts and a lot of boldness. So you feel that this quality is intrinsic or it can be promoted through education?
uh, I think it is partly intrinsic. But then, if not promoted through education, it can be promoted through our habits of understanding things. Like, if we say, what should be the characteristics of a researcher? If we ask a question, what should be the most important characteristics of a researcher? So, I believe it is inquisitiveness, and most importantly, asking the question and answering the question why this is so. Why
Einstein
this is so.
also said, yeah, Einstein also said the same thing. He said, I
Okay.
was not particularly bright. I mean, Einstein said about himself that he was
Yeah.
not particularly bright, but he was inquisitive. And he
Right.
always says that this curiosity is more important than knowledge. Because if somebody
Absolutely.
asks a question,
Absolutely.
yeah, so he's likely to
Because
find an answer.
a unique question which has never been asked before gives us the opportunity to answer it. And that answer becomes a unique answer which had never existed before. Because then it creates a new knowledge.
Yeah.
It's not the previous knowledge that we are analyzing or doing something with. It's a new knowledge. So this
Do you think
inquisitiveness.
Hmm. Do you think our education system, the existing education system, which has been in place for quite some time, and despite the fact that new education policy has now been enforced, do you think the system is perfectly suited to promoting the curiosity and this element of, inquisitiveness among the children, or it needs some tinkering?
Unfortunately not. If you if you look at the current status of the education system, what we are currently facing, crisis that we are currently facing, if you look into it and look into the temperament of the education system, if you look at the, say, the government organization, the education has been reduced to the organization's ability to attract funds. And for private sector, it has always been about earning money for the stakeholders. Okay, so it sounds much more about money than education. So of course it requires a lot of tinkering, and those tinkering should be uh, from the grounds of developing and inculcating a good research habit among students, even if
What
at
was,
the undergraduate level, because
yeah,
the habits need to be inculcated, needs to be instilled in the undergraduate level. Only then it becomes a habit at the postgraduate or PhD level.
So
So
what you
at
are
very early
suggesting
age, we
is,
must uh, imbibe this.
yeah. So what you are suggesting is that the change has to be made at the elementary level, then in the education, say at graduation or post graduation. But even
Right.
after that, if you compare the industries in India and in other countries, particularly in the US, there is a big difference between the two. The industries in the United States support research even in the universities. In
Right.
India,
Right.
this is something more of an exception than a rule. So, what would you suggest? How can we improve this point?
This is because you see, I think, because people at the end, it should boil down to earning money. You know, now we have to convince our industries that if they invest in R&D infrastructure, if they employ good researchers, they will save a hefty amount of money that they spend in licensing their products by actually having their own IPs, own ownership of intellectual property. Okay, so if there is an in-house R&D, their own, it will be their own and ownership, and they can dictate terms with the technology that there is. So currently they are investing a lot of money in acquiring the IP. So if they generate the IP, it is theirs. Everything is theirs. Okay. So our industries and our startups, because this is nowadays we have more focused. We are more focused on the startup ecosystem. But unfortunately, the startup ecosystem doesn't have this culture of R&D. You know, they are buying things, buying the technology from outside and doing something
Yeah.
with it.
So, what
So
can be done? What can be done?
every startup should mandatorily have an R&D division.
Component. Yes.
They should have their own IP first, and that IP should be used for their production, the products. So, first, what is the need to do something, and then contact their own in-house researchers to solve a problem, get a product out, and then because they are generating the product, they are creating the product, they will have the entire IP, and the
But
country will be that when we talk about Atmanirbhar Bharat, we are actually not completely Atmanirbhar because we are still asking for technology from outside. You see that
uh,
even the
I
current
agree with
situation
you.
current situation, say France, Dassault, they are we want, say for example, the Rafales, where we need to integrate our own weapons in that. So France is not giving us the source code, okay, because that is their IP, their intellectual property, right?
You cannot
So
expect this kind of investment by the startups. Startups are generally by people who are at the very young stage of their career, and they are not in a position to invest say crores of rupees. Forget about billions. They are not in a position to invest huge amounts. So, what can be the strategy so that I don't think that startups will be taking up R&D in a big way, but the established industries, we have industries in our country which are billion-dollar industries. What should be done to promote or encourage them to take up R&D? Like, can the government make a kind of a rule that okay, 5% of your total turnover should be directed towards R&D or something like that?
absolutely, absolutely, the established industries should try it. But I have something more to say. When we talk about R&D, people think it requires a lot of investment. Now let me tell you a very simple thing, very my example. The uh, Shockley's equation, which I replaced with my modified general diode equation, that has a tremendous industrial implication. What is the cost of R&D in it? Absolute zero. Absolute zero. Because I did not even have to experiment, because the experiment results of diodes are already available in data sheets from industries. Okay, so I just proposed my own equation. That's a new, the new creation creates a proper understanding of the thing. When we write codes, say for example, to say we have a simulator which generates the diodes characteristics, for example. So a simulator, much better simulator, with much lesser resource hungry simulator, an agile simulator, you know, and completely new IP. Okay, so there are a lot of things which we can do even without investing a penny. You
What
need
you,
good
yeah.
researchers in your R&D organization. Identify them. The patents which are already available, they can also be taken up. So
This
it's not a
brings
huge investment.
to, yeah, this brings to another thing. In many of the, and this is not a problem typical to India. This is a problem for most of the countries because I remember as early as 30 years ago, in the New Scientist, a British magazine, they said that most of the patents that were done, hardly any one of them was commercialized. Very few of them were commercialized. So in between, in India too, we had a culture where everyone said, go for patents. And we went for thousands of patents, but very few of them have really been commercialized. So do you think there can be some kind of screening in the beginning or some such thing so that people just don't go blindly for the patents, but for those patents which can be commercialized?
We should. Actually, the patents which are being filed these days, they are mostly a kind of a application patent. So, if we see, the patents should be more focused on the utility patents. In the United States, that's called utility patents. That means you are approaching it from the theory. So, a theory which leads you to the practical. Now, the current patents do not have any theory linked with the practical. So, that means what? Your single patent is applicable to a single scenario. But suppose my patents would be, because those are utility patents, those would be applicable to multiple scenarios. Okay, a single patent gives you the liberty to apply it in multiple scenarios. Okay,
So what you are
so
suggesting? Yeah,
yeah, this
please.
is one thing, and of course, the point that you said, these I can see just as rightly said by you. It is there are thousands and lakhs of patents in our country which are just bogus, absolute bogus. They have been even granted, not just filed but granted, bogus things. In one of the IEEE magazines, Spectrum magazine, if you have heard about
Yeah,
that magazine,
yeah.
almost 10 years back, I saw that they wrote that one can even have a patent with a simple thing like crisscrossing a bristle. So
Yeah.
on your toothbrush. So if the toothbrush has straight bristles, and if you just crisscross them, and
Okay.
that
Yeah.
and you prove that this has it does something better, it becomes a patent. You see, it is and people have done so, patented those.
Yeah.
So
But
there is also a category of design patent.
yeah.
So
Yeah.
so we have to distinguish these properly, and the industry should have the ability to identify the patents properly. The industry should hire people who can identify the researchers with credible patents applicable to the industry. Otherwise, among these lakhs and lakhs of patents, it is difficult to find out which one is actually worth noticing and worth taking up in the industry.
I think there is another problem that patents have been related to promotions and appointments and so on.
Yes,
So
yes,
I think not many people will understand the real worth of the patent. What they care about is the number of the patents. And
right,
therefore, there is a tendency to go for as many patents as possible,
right,
immaterial
right,
of whether they have any utility or not. So that is
right.
one thing.
Absolutely, absolutely.
But people complain that in India, there has not been a culture of innovation, whereas some people strongly differ with that. They say we always had a culture of innovation. So, what do you think is the real thing?
I think those who say that India did not have or does not have a culture of innovation suffer from a syndrome which may be called a slave syndrome. Slave syndrome, as simple as that. Because in the British Raj, we were systematically taught, in an
Yeah,
implicit way though, we were systematically taught that we are worthless people, so that we stay as their slaves, and do nothing, say nothing. Okay. And unfortunately, that culture and that kind of a teaching has percolated through years and reached the current, current generation or the
Generation.
previous generation. And
Yeah,
that is
yeah.
why these things, these kind of thoughts come. Nonetheless, if we look at our prehistoric, pre-Islamic history, prehistoric is fantastic, but even if we look at the pre-Islamic history, our culture is full of scientific and engineering marvels. And now we have started realizing that yes, if we try, we can be one of the best people in the world in terms of science, technology, innovation, and all these things. We
So
have
this
started
again,
realizing. I
yeah,
mean, uh, I should be frank and candid that the current government, I do not know how government is related to it, but during the period of last 10 years of the present Modi government, you see that there is a lot of, change. Although I study about history, I studied about Indian prehistory, and I had this understanding lot, long before, like from 20 years, I had an understanding that yes, we are worth a lot. So maybe that gave me the confidence to challenge things more. Maybe because I had this understanding, say, for the past 20, 25 years.
so if you are asked, say, two or three suggestions for making some changes in the education system in the schools, what would they be so that you can promote the culture of innovation?
Well, first of all, I think this is very important that our approach of any kind of a study should be heavily vetted. Suppose if I say something, if I state a law, for example, Newton's first law. Okay, so this should be heavily vetted. Why did Newton say all these things? Now, for example, Newton's first law says uh, a body moving in a uniform rectilinear motion will continue to do so unless acted upon by an external force.
Yeah,
Okay. Now, people forget to ask a question. Why did you say uniform rectilinear motion? Why? If it is non-uniform, what will happen?
yeah, yeah.
And if it is not rectilinear, not in a straight line, why? So why has he included all these terms inside? Okay. So our basic approach has never been so. I remember in my school days, and still people believe that if I move from point A to point B and from point B to point A, my displacement is zero and the work done is zero. Because my
Mm.
displacement is zero, my
Yeah,
work done is zero. That means even if I say do a lot of exercise with bucketfuls of water from say point A to point B and keep
yeah,
doing that,
yeah, yeah.
after doing everything, they'll say you have done zero
Not
work.
zero work. Yes.
So this actually challenges your common sense, doesn't it? But we still accept it, right? So
I
here
think,
is the problem.
yeah. I
Here
think
is the
in
problem.
schools there should be more of discussions in the class rather than one-way communication.
Right,
You
right,
very rightly said that when the Newton's first law is taught, the teacher generally does not discuss why every adjective has been used. Why did they say rectilinear motion, or why did they use another adjective, and so on. So I think in a class of 45 minutes, if there are 20 minutes for teaching, there should be 25 minutes for interaction. So that
right.
is one thing which is very much missing in our class. So I agree
Yes,
that this is one change which must be made in our education system, particularly the elementary and the early education. Now,
right.
when they cross the 10th standard and they come to 12th and to graduation, then all of a sudden the burden of books, the burden of syllabi, all these go up. Now, children generally don't want, it's difficult for them to adjust to the new pace and the new amount of burden they are facing. So, what would you suggest to do this? And second thing, in the early stages, when they are, say, in fourth, second, third, and fourth, emphasis should be on what? Should it be on acquiring more and more information and knowledge, or it should be to increase their natural abilities?
You were talking about second and third year of graduation. What are
No,
you talking?
no, early
Okay,
stage,
early stage. I mean, you
yeah,
mean school days?
school days.
Yes. So of course it should be about this kind of inculcating the thought, how to think. People should actually be focused telling. I mean, the teachers should tell their students and generate a habit in them about thinking, rather accepting things right away without giving it a thought.
Yeah,
So that habit needs to be inculcated, and once that happens at the elementary level, that gives a very very great advantage. I think that has been a very great advantage for me. I was not uh, like I was taught in the normal schools where there were no such practice, but I had that personal habit. Hello, are you
yeah. Now I can hear. Yeah,
okay? So could you hear the past statement?
no, no, no.
Oh, okay, okay. So what I was saying is that in my school days, I had this habit of questioning everything which was told. Okay, so I would spend say hours in my school days in say class five, class six. I would spend hours in giving answers to the questions which I have and which my teachers don't answer. Okay, for example, I tell you what, I um, I was perhaps in class seven or eight. So I have a problem of this short-sightedness, myopia. I have glasses, right? If I remove the glasses, I can't see things clearly. Okay. So I was once looking through a small hole, and I started uh, seeing clearly. Okay. So went and asked my teacher that why is this happening? So teacher said, "Don't ask me such rubbish questions. I can't see through a hole clearly. Why do you see a hole? I can't answer this." I went and asked my father. He also said, "That's go away. You ask all of these foolish questions." But I did not leave that there. I started studying books of higher standards. Later on, I understood that I took a class 9 book in class 7, and I read that there's something about myopia, and I have a problem of myopia where the image gets generated before the retina and so forth. So and then, but I could not still answer what it was. Then when I was in class 8, I read the book of class 12, and I read wave theory, electromagnetics and wave, all these things. And then I created my own answer after reading the wave theory, lights and waves. I created uh, the answer to this question. It doesn't exist in any book, but I have that answer for me. Okay.
Yeah. So I think one is that individual's ingenuity. This is one thing. But what can the system do to promote it? For example, you were one exceptional person who took it upon yourselves to try to find the answer. But in general, not many students would be like that. So, in what way our education system can be helpful to them? Can there be some kind of alternate track for them? One is the school education. But other than that, what uh, uh, can we can make affordable to them are available to them where they can learn things on their own? What would you suggest?
Well, I think from the very beginning, once you pose challenges to yourself, once you pose challenges, like you see, uh, when one is dropped straight away in water, who doesn't know to swim, how to swim,
Yeah,
will somehow swim out
yeah,
because it is the question of his life and death. So
yes,
if we actually make a person force a person in an environment where he is forced to think about things. For example, our examination system, let it be not. based on what is taught in the class.
Yeah, not only on
Pose
that.
them a question which is out of the book.
Yeah,
It happens
yeah,
in IITs. I had
yeah.
faced open book questions. So even if you bring 12 books, okay, and you
Yeah,
open, you will not find the answer to the question which has been asked. So it's better focus on the question rather than searching the answer in the book. Right?
that's true. That's true.
So the thing is, pose them such questions which enlightens them, which opens up their circuits of their brain. Okay.
Which means modification or improvement is needed not only in the education system, but also in the examination system.
Right, right. Yes, because and examination is a part of the entire education system. Another
Yes.
thing is the clarity of what we are doing. For example, in science and engineering, you know, people do not understand, cannot differentiate between science and engineering and the importance of both of these. For example, we must know that science and engineering, in practical sense, cannot survive without each other. And secondly, engineering is a special act of humanity. We have to understand. Say, I'll quote one one statement from Albert Einstein. He said, "Scientists investigate that which already is." Okay, scientists investigate that which already is. Engineers create
Mhm.
that which has never been. So engineering is a act of creation. Now,
Yeah.
when a person goes into engineering, should understand how serious the work is. How serious the work is. So only a select group of people would realize that yes, understand one's ability. Yes, can I create? Can I create? If I cannot create from the science that I have learned, should not opt for engineering. And engineering, and we see engineering just as an application of science. Of course, it's an application of science, but it is also about creation. For example, we have been fabricated by, say, our parents, but we have been engineered or created by God. God knows, God did just the calculations, you can see. Okay, so
Yes.
we have been made by our parents. So those who are say for example, one who is constructing the building, it's the mason, right? It's the masonry work. So we don't say the masons made this building. It's the engineers. They know what should be the actual composition of a beam, how far they should be located, the columns should be located, and what should be the how far the beam should be located, right? And what should be the composition, and then they can predict, oh, this can survive for 100 years, so to say. So the thing is that we have to understand what engineering is. It's the act of creation. So God creates whatever is living, and engineer creates whatever is non-living
Yeah. And
and
that brings us
non-naturals, of
to,
course.
yes, another very interesting things comes up. We have engineering and science both. There are many engineers who switch over to, particularly in the Western countries, there are many engineers who switch over to science and do outstandingly well. We know of at least a dozen Nobel laureates who were basically engineers. They got Nobel Prizes for science. And at the same time, there are scientists who switch over to engineering. But in our country, perhaps such a switch over is not very common. So, any comments on that?
It is required, and we should not think it as a switchover.
Yeah.
For example, if you go to America, there is no such bachelor of
The-
engineering separately defined. They give bachelor of science, master of science. Okay,
yeah.
even in United Kingdom. So the thing is, the scientists which we had, they were both. They were scientists as well as engineers. So
Hmm.
engineering can be thought as a part of science. We should think it as a part of science if we cannot switch between them. You must have the ability
Yeah.
to switch
Yeah.
between them. We
Yeah.
engineering, if we do not do a scientific analysis, we can't do engineering. If I could not have created anything if I did not have the understanding of physics, if analysis of physics, right? I could not have done
Yeah. Yeah.
that. As simple as that. So the thing is that we should not, they should be inseparable, as I told initially, that they require each other to survive. And we should we should have no hesitation in switching between these two. And the habit of creation will help science, and the habit of scientific analysis and inquisition will help creation.
Now, in case of different disciplines, in science, we have a lot of disciplines. In
Right.
our country, they are very compartmentalized. Physics, chemistry, mathematics, zoology, or botany, or geology, and all. In Western countries, these borders are gradually vanishing. But in
Yes,
our
yes.
country, they are still very watertight compartments.
Right, right.
So, do you think it's okay, or should we also change?
We must change. The borders are black and white in our case, and there there the borders the borders are grayish. You know, they are intermingled with each other. So this is always a natural thing which should be allowed. We should not separate it. It is something like, if a crime is committed in a particular area and one goes to the police station to report it, the police says, "Oh, no, no, don't report it here. Go to that that
Thana,
police
Thana.
station because it comes under that area." You know,
Yeah,
so that is,
yeah,
and instead of dealing with the crime and suppressing it, they are actually just passing the buck from one person to another. So if we do draw such hard lines,
yeah.
for, and perhaps it is not possible, it is not logical, it is whimsical to draw a line between them.
Yeah, because nature doesn't make distinctions. For example,
Yes, nature doesn't, and we being part of the nature should not do this. It is foolish to do it.
a
It is
rock
foolish to do
which is lying outside is exposed to chemicals, is exposed to the sunshine, is exposed to the mechanical forces, is
it. Right.
exposed to other things. So, if somebody wants to really study the history of that or evolution of that rock, he cannot say, okay, I will just do the chemistry or I will just do the. This is perhaps only a matter of convenience that we divide them into different disciplines. So that up to
Yes.
certain level, they specialize in one particular thing. To
Right.
some extent, in our country too, these lines are gradually diminishing. They are fading,
Yes.
and
For
people
the
are
better.
switching for
For
the
the better.
better, for the better. And we see it in IITs all across the country. Another question: in the last decade or so, in the last 2 decades, uh, many new IITs and NITs and NICER and whatnot have been built up. So, do you think it's good or bad?
I think that quality and quantity are always inversely proportional. It is naturally inversely proportional. We
Yeah,
create a lot of quantity. We do not require so many engineers. Good engineers are required in very less numbers. We can do other things. So we do not require so many colleges. We are focusing on the quantity everywhere. In academics, the teachers are told to have large number of publications so that they can have large number of citations.
yeah.
I mean, the main focus on what the basic thing, what the topic that you're taking up, how impactful it is, what impact will it make in our society, or the fraternity of science and technology. No such thought. Just do incremental research, do all mumbo jumbos, and keep minting papers like in a press. I mean,
So this brings us to
press
that early
press machine.
point, another point we discussed about the school, that it's not only the teaching, it's also the evaluation which contributes to the overall quality of education.
Absolute,
Like
absolute.
just judging somebody by number of publications is not a very good thing to do. And very recently, Pete Higgins, the man after whom this so-called God's particles or Higgs bosons are named,
Name.
he said that uh, in this
Yeah,
age, I would have been fired long back because
that's true. Yeah,
I researched for so many years and then produced just one or two papers. So that I think has been a change in the culture of research everywhere.
Yes,
this
this statement came
publisher
up, I think,
perish.
almost 2 years back,
No,
2 to 3 years.
very recently I read somebody
Okay, okay.
after,
But
yeah,
this actually statement came almost 2 to 3 years
yeah,
back,
yeah,
and I
true.
posted in my Facebook as well. Uh, so,
Okay.
uh, so this is absolutely true. I mean, if there were Einsteins and his Newtons and great research workers, they would have been fired by now. They would have been just rotting
Yeah.
in their homes and doing
See,
nothing.
Einstein was working on that general theory, and later this combining all the forces together on that work without producing any paper. So I
Right,
think,
right. The unified field theory.
so how do you judge an engineer or a doctor? Somebody said that it should not be the number of papers or even the citation or even the journal in which it has been published. What is published is more important than where it is published, number one.
Right.
Number two, instead of judging in terms of citations or in number of publication, a scientist or an engineer's work should be judged from the impact his work has made in his field. Now, this is something which is a bit, subjective.
Yes.
Number of papers sounds objective, whereas the
Right.
impact is a bit difficult to evaluate and may have some subjectivity. So, how do we get
Right.
across this problem?
First of all, we should look for evaluators, proper evaluators of academic work. Now, when we appoint evaluators, we should not look at the number of publications that he has. First of all, in general, usually if you see, there are a lot of researchers having huge publications, but hardly one or two publications where they are the first authors. Most of the work have been done by their students.
Yes.
Look at the articles where he's either the lone author or the first author,
Yeah.
and see the kind of work he has done. Which journal has it been published with? It is an initial screening is also important.
Yeah.
For example,
Yeah.
if it
Yeah.
is not published in an SCI journal, it's actually not worth it. So, number of SCI publications, and within the SCI publication, how many of those have him or her as the first author, and how impactful it is can be understood by reading it in a way, or kind of citations, and who has cited it. Has it been cited in a journal or a conference? Has the citing is the citing journal an established journal? Are
Yeah.
the researchers who cited them are established in some good organizations, like say IITs, or say California University Berkeley? Like my signal paper got cited from California University Berkeley, MIT as well, right?
Yeah.
So the question is, now you form a set of evaluators who actually have an academic value, not by looking into their number of publications uh, alone. Okay, quality publications, that can be objectively done as well,
I
because
think
whether it
this
has,
is, this is very important. The point which you raised, that evaluators' qualities are also very important.
very,
And if those people are not honest and they are not really that competent as they are expected to be, and then the evaluation is not going to be good. So I think we have come up with certain new ideas, like what changes should be made in the education in the early stages, where children should be more focus should be on making the children inquisitive rather than memorizing. In as far as the industries are concerned, it should be mandatory for them to invest in research, R&D, and maybe government can form a rule where certain percentage of the total turnover has to be invested in research. Otherwise, they will be
absolutely.
de-recognized. Otherwise, we are just doing the screwdriver technology, where things are imported, we assemble them and sell them off. So that's not a cult, because we repeatedly we go on paying for IP of some other country.
True,
IP
true.
is very important. Countries like
Right.
Finland are there.
Yes.
Countries like Finland, totally their economy is totally dependent on their innovations and inventions.
Right. And it drain and by the way, Finland is one of the richest countries,
It's one of the richest countries.
almost at
Yes.
par with Luxembourg. Luxembourg is the richest in per capita, say GDP.
Yeah.
but Finland is near, right? So even America trails behind a lot. So you see that IP drains away a lot of money if you do not have an IP. And if you want to do technology, want to do say good scientific work, or I mean the production based on science, novelty, and all these things. So you have to buy IPs.
So
That's the
you
thing.
made another valuable comment that startups also should be encouraging R&D, even though
Correct.
their funding is limited. But every time they don't have to spend on huge instruments or things like that.
Right. Right.
Even otherwise, I think in our country there are a lot of instruments which are now in the common slot. People can pay a little bit and get the measurements done.
Yes, yes,
So,
yes. A
so I think
common facility, and government has
common
also
facility,
started it. You can
right?
see that in IISc, you can see that in IITs. They are open to researchers to come and measure and do all those things.
So with these common facilities, even startups can think of investing into R&D because, as you said, that if they get good scientists, then their R&D quality would be improving. So this is also a message to the government, to the industries, to the scientists, and to all the entrepreneurs that they should be investing in R&D also. Unless
Right.
we do that, the country will not progress. Look at the example in the recent war we had, 3-day war we had with the Pakistan. The instrument or the equipment that we used or they used are exorbitantly expensive. And most of
Yes.
the price has gone because of the IP thing, because we are buying we have purchased a finished product from some other country. And the cost wise, it may be a small fraction of that. So whether it's defense, whether this is some industrial application or any field, we have to go for R&D. So thank you, Professor Pragyan Chakrabarti, for a very, very enlightening and illuminating discussion
Thank
uh,
you,
at
sir.
this at this Zena platform. And you shared with us the great memories of your experiences in India and in France, and the wonderful work where you even agreed to disagree uh, with the Nobel laureate, which was something really bold to do. And you clearly showed that life keeps throwing new challenges. But what decides our future is how you react to them. India needs innovation, India needs inventions. And this is very important for the industry if they want to grow at a rapid rate. You have shared wonderful tips for the future entrepreneurs also. And this comes naturally to you because perhaps because you have had a long teaching background. So thank you so much for your time and providing a new canvas to the young generation. And this is Zena platform, and everyone associated with Zena is also thanked for making this possible. Thank you so much.
Thank you, sir. Thank you. It was
Namaskar.
great talking with you, and you also provided a lot of insights into things. And I think this discussion was great for me as well. Thank you.
Thank